over to particle effects. I just want to see what it says. Particle systems. It's in rendering. Particle systems comes under. So this is the cascade one, and then the newest one is Niagara. I wonder if that's going to be. They have in here.
Try searching. Yeah.
Let me know. Okay, so it's just in a, it's just within a feature now. Okay, so we have the newer one there, and then if we go back, we'll have the old one here. So the old particle system, creating particle system, and this is the older system. Then does it?
I don't even want to see it.
Okay. Well, it seems that there's a lot of documentation on it as well, which is nice considering it's a new feature. So we had to get the latest version of Unreal for this. By the way, Horangi, nice to see you. How you doing today?
Oh, you didn't download it yet?
I did. I just didn't open it. Okay. So I'm just letting people know that if you are going to try and do this yourself, this is you need the latest version.
It actually asked me to restart my computer. I haven't done that.
I downloaded it and thought it installed yesterday. Let's hope it doesn't ask me to restart.
Yeah, let's see.
I press launch? I think I pressed launch.
It felt like you pressed it. I saw the button feedback.
Okay, it's not doing it. Shh, just be patient. Okay, while waiting, we can look at this.
Well, first be patient, then try again.
Deep and meaningful. If first you don't succeed. Okay, so the Niagara VFX system is one of two tools you can use to create VFX inside Unreal Engine 4. Before Niagara, you used to be able to use something called Cascade. While Niagara has many of the same particle manipulation methods that Cascade offers, the way you interact and build these things with Niagara is vastly different. The page links to documentation about Niagara, a quick overview, Getting started, a high-level overview of the editor, quick start guide, key concepts and design philosophy behind Niagara. You can also check out guide section that has how-to on various tasks. The reference section has the system and emitter module reference, the Niagara editor UI reference, and Niagara script editor reference. Okay, I've had some progress in terms of it asked me if I want to trust Unreal to install something, so at least it's doing something. So Niagara overview, let's have a little look in there. Hey Paradigm System, nice to see you. Okay, so they're both used to make visual effects inside. So they tend to call them visual effects rather than particle systems. Okay, so it uses Unreal Engine's next generation VFX system with Niagara. The technical artist has the ability, we're technical artists for the next month, has the ability to create additional functionality of their own without the assistance of a programmer. We have made the system as adaptable and flexible as possible while making it easy to use and understand. So there are 4 core components: systems, emitters, modules, and parameters. So I can guess what some of them are. So the parameters is going to be like you feed in data and it uses those data in order to that data to do it. So that might be in the same way that we add our animation, we pass our speed in and it'll use that data. The emitters is the way that things it generates visual effects. If I remembered, it emits them from a location.
It spit out tiny particles.
Yeah, and what systems then? That's the bit. I guess systems and modules.
So systems are, so you can have multiple emitters in a system.
Right, that makes sense. Yes.
Imagine you have a smoke emitter, so you can use that smoke emitter to create a cloud system, as well as you can also place it in a explosion system where you have smoke after an explosion. You can use the same emitter in different systems.
Yeah, that makes sense to me. That sounds good. Cheers, dude. Hello there, Flippo. There is the wonderful Brainoid. Pardon,
Am I
system.
echoey?
It's just because you've got a lot of space in your in your apartment. You're not
I will
ma-
hide in a box.
You're not massively echoey. It's just that's the only echo I believe. Um, Power
I
down.
guess I
I'm
get echoey when I speak louder.
Yeah, probably.
Sorry.
Um, Power down system. I have been okay, man. I've been pretty good actually. Things are going okay at the moment. How about you? And then modules. Did you know what a brief summary of modules? I get it's going to explain them now, so I might as well read through them. Niagara systems are containers for multiple emitters, all are combined into one effect. For example, if you're making a firework effect, you might want multiple bursts in your firework. To do so, you'd create multiple emitters and place them all into a Niagara system called Firework. In the Niagara system editor, you can modify or overwrite anything in the emitters or modules that are in the system.
I hate this documentation really. Like it asks you to look into another documentation to understand it. So
This stuff, yeah.
like it says modules are the equivalent of cascades behaviors. Okay, but what if I don't know about cascade?
Yeah.
Do I?
Yeah. So basically saying you can overwrite within a system, you can override anything in the emitters or the modules. The timeline panel in the system editor shows which emitters are contained in the system and can be used to manage those emitters. Emitter editor and system editor are mostly the same. Okay, so emitters, Niagara emitters are containers for modules. They are single purpose, but they are also reusable. One unique thing about Niagara emitters is that you can create a simulation using the module stack and then render that simulation multiple ways in the same emitter. Continuing our firework effects example, you could create one emitter that had a sprite renderer for the spark and a ribbon renderer for the stream of light that follows the sparks. More information, blah, 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 blah. Okay. Modules. So Niagara modules are the base level of the Niagara VFX. Modules are the equivalent of cascade behaviors, like Ryan said. Modules speak to common data, encapsulating behaviors stacked with other modules and write functions. Modules are built using high-level shading language. I've seen that HLSL before, but can be built visually in the graph using nodes. You can create functions, include inputs, or write to a value or parameter map. You can even write HLSL code inline using the custom HLSL node in the graph. For more information on default value, we're going to look at that. And then finally, parameters was the fourth core component. So parameters are an abstraction of data in Niagara simulation. Parameter types are assigned to a parameter to define the data that the parameter represents. There are four types of data. You have primitive, so this is stuff, numeric data. Then we have enums. This is a type, a fixed set of named values. Struct, this is a combination of a primitive and enums. And then data interfaces, which is defines functions that provide data for external data from external data sources. So this is your way to interface. The word interface tends to mean the way that like two systems can communicate between one another. So I guess this is the way that our particle systems can then, there's functions or whatever that can be used that other parts of the system can access. So that's how I'm imagining this is going to piece together. Still working from home at the moment, Paradigm System. I imagine we're gonna, because we can. I think the government's thing at the moment is work from home if you can, right? And we're not too restricted from working from home, so we'll probably continue it for a while, I think. We've been creating homemade English muffins this morning. The dough is rising now. We're playing the goose game until they're ready to grill, and then we'll use them to make sausage and egg muffins. Well, that sounds like a good start to your day. It's the Untitled Goose Game. Okay. Yeah. Okay, stuff like this isn't essential to read right now because we haven't got it open in front of us. Is Unreal opened? Okay, so a new project, a new game. Next. Did you just go blank? I'm wondering if there's going to be any...
I went blank.
Okay.
Well, actually, starter content has some particle textures in it, but
Yeah.
I can provide some to you. Don't worry.
I don't mind starting with... I think I've got that anyway, so we'll just do it for now. There's no issue. Okay, this is going to be particle. Okay, so while that opens up. Hey, Apollyon, thanks for the host, dude. Okay, so Niagara stack model and stack groups. Particle simulation in Niagara operates as a stack. Simulation flows from the top of the stack to the bottom, executing programmable code blocks called modules in order. Crucially, every module is assigned to a group that describes when the module is executed. Templates and wizard. Okay, so you can make new systems in this way. Okay, so the workflow might be more useful than looking at that. Oh, we're in our classic level. Look at this. It's so shiny. Okay, great. So we're in the world. We're not going to read through all of the documentation because that would take the entire stream length. But it's just to try and get an idea. This workflow thing here would be interesting just to read this. So when you create emitters, you place modules in the stack that define how that effect will look, what actions it will take, and so on. If the emitter spawn group, or in the emitter spawn group, yeah. Sorry, for me, I thought that whole thing would be bolded, not that. But anyway, place modules that define what will happen when the emitter first spawns. In the emitter update group, okay, that makes more sense now. Yeah, place modules that affect the emitter over time. So we have a spawn, so that's like an on creation, and then we have an update effect, right? Yeah. And then in the particle spawn group, place modules define what will happen. Particle spawn. Okay, that you're saying the exact same line, but using the word particle instead of emitter. Okay, in the event handlers group, you can create and generate events in one or more emitters that define certain data. You can create listening events in other emitters which trigger behaviors and reactions generated. It's all a bit wordy at the moment, isn't it? Yeah, we're just having a look at the overview now. Oh yeah, you're right, actually. We should have probably done the quick start rather than the overview. So quick start will just get us through like what to do. Right. So they've done like dust particles on the feet. Yeah, so I don't know, Brain, I was going to say, if you want, you could try and show what you know already.
Okay.
And then I can try and follow through this quick start thing, because it looks quite long, so, you know, it might take a while to go through. It'd be interesting to see if, just get a little introduction from yourself first. Because you said earlier that you've had a little bit, and you can show what you've found out so far, if you wanted.
Yeah, I mean, so first of all, we need to create a material for the particle, right? That applies for all of the particles we're gonna create.
Right. Okay. So a material would just
like go right click. And
yeah. But so I'm just thinking from a very basic point of view of a material. We're used to using materials as a way for like, is that the same as textures, or is it what you assign a material to a static mesh normally, right?
Yes, like a material is like you have a shader in the material, and that shader usually does some computing using textures, and that's the material, right? So
yeah,
we also use those materials in particle systems
yeah.
because we're gonna render stuff using those materials.
Yeah. Okay. Like that's all right. Like, because for me, it's not instinctive, so I want this to be like as easy to kind of grasp as we start. So materials are our way to show things, basically. So we use them for both like normal static meshes and for this sort of stuff as well, right?
Yep.
Okay. Just because the term
So
material itself isn't like I don't know. I don't think I understand the difference between the term material and texture. And I think texture is something that you've pre-made, like an image that you bring in, whereas material
well,
is
texture is
a
just an
shader
image.
graph.
Yes, texture is just an image, and the material is how you interpret that image.
And you can combine the normals and stuff like that, can't you?
Yeah. So
Yes. Yeah. Yeah. That makes sense.
let's look at this. This is the cloud material I created.
Okay.
So I used this texture. Where is it? Smoke. I used this. Oh, sorry.
Okay. So it's like a
Oh, it's a
comic book,
sprite sheet.
a flip book, basically. Yeah, a
Yeah,
sprite
it's
sheet
a
of the
sprite
different
sheet.
stages of it. Yep.
So it's an animation already.
Yeah.
Okay. You don't have to use an animation, but Niagara also has this system that you can uh, use this sprite sheet as an animation and then also animate it using other attributes like
Okay.
speed and stuff. Okay, so we're using this, as you can see here. I clicked this and changed this to translucent first
Okay.
because we
Yeah.
want it transparent.
Okay.
And I added this particle color because like we will be going to use the particle system's color parameters.
So particle color is just a node that's already in there, right?
Yes.
Right. Okay.
And then we multiply the particle color with the texture RGB,
Okay.
and yeah, attach the base color here.
Right. Okay. So the multiplication is just your way of saying apply that whatever color we give it to the white bits, if that makes sense, right? Of the texture.
Yes, and also we use the alpha of it to like RGBA, right?
Okay.
We
Yeah.
use the alpha of it and multiply it with this
The alpha
alpha.
values of that. Right. Okay.
Actually, it should be RGBA, isn't it? No, didn't work well. Okay, this is better. All right.
So that means if you change your base color to be transparent, it'll also make the smoke bits transparent as
And
well.
also sometimes you might want to do attach it to emissive as well, but here I'm not sure. Yeah. Maybe.
So emissive is like a glowing effect or something, isn't it? Like it emits color away.
Yeah.
Right. Okay.
It emits light.
Right. Okay. So it generates like a light effect.
Okay. And then I created. Let's go here. I created an emitter here.
Okay.
So this is my emitter, PE, particle emitter cloud. So you cannot drag and drop this into the scene.
Right.
Because you need a particle system. You can drag and drop a particle system.
And the system has
you
the
create you create. Well, you can edit this one in this editor, but you won't be able to just edit in. So you create a particle system that has the emitter in it.
Yeah.
So that's the way. And yeah, this is a little scary, I guess, to look at in the first time. Let's see. Lots of things.
Lots of properties there on the side, isn't there?
Yeah, and also you can add many more here.
Oh, good. I wanted more.
This view is good, I guess, because like you get lost in here, but you can filter
Oh, okay, yeah, that's nice.
Those Premiere.
That's a
Yeah,
lot
I
more.
like that.
I like that a lot as well.
And if you get used to this look, I guess you can navigate faster. So these are, I guess, simple. This starts with CPU simulation by default. I changed it to GPU. I'm
That's
just
just what
testing
it's
things out.
Is that just what it uses for you to render it
Yes.
now? Yeah.
As you can see, there's a timeline here as well.
Yeah. Did it
So
generate that automatically, or
yes,
when you
it
bring it
did.
in?
Yes. And so let's look at my particle system. It looks the same as you can see. And I only have one emitter here. Actually, I want this here. Okay.
So, sorry, what were we in a sec ago? Was that the particle system we were in before? No, the emitter were we in before?
The emitter, yeah. So they look the same. The only difference is that you can have multiple emitters here in this timeline.
Yeah.
Right? Yeah, so I guess that's it. And let's go here. Yeah, you can see the particle system clouds.
That's what. Oh yeah, that's the thing that you brought. Oh no, that's this, right? That's an overview for the whole particle system.
It has its own properties.
I'm guessing the new Niagara emitter is the imported clouds PE or PE cloud.
PE cloud? Yeah, this is the. It didn't rename it. I actually renamed it. It was new Niagara emitter. Yeah.
You can see it at the top right. Anyway, it still does say PE cloud. Oh,
yes.
There we go.
Silly. All right. So nothing fancy here. I mean, I don't know what fixed bounds is really, but it forced me to tick it because I changed to GPU.
Right. Okay.
Let's skip this bit.
Yeah. So this is the the things that you can make it happen when it spawns and things to happen when it
emitter
updates.
spawns like spawn particles in grid, spawn per unit spawn rate. You can add things like that. But here this is by default. It added spawn rate under emitter update. So that's
right.
Confusing. So emitter state is mainly about like, is it looping? Is it like looping once, multiple times?
Right.
Things like that. And scalability mode. Do you scale? If you try to scale it via code, I guess, does it scale according to system scale, or is the local scalability? I guess that's it.
Right.
Yeah, spawn rate is spawn rate. You know what it is.
Well,
right?
kind of, but I'm trying to think. Like you've got off that image you had earlier. Is that loads of little versions of it, and it's spawning like 50 of them altogether?
I changed to one.
Right, so it's just doing one and then another in a random location. Yeah, that's a bit because like when there were so many of them, I didn't know if that was the whole image of the animation. But no, each one of these should be identical, or no?
They are identical, yes. But like you create variances with rotation, scale,
yeah. That sounds good to me. It's just like making. I think understanding what you got at the very base level and then building on that helps rather to see. So yeah. So at the moment in this emitter, we're saying not only are we saying here is the animation you're going to be using to spawn something, but we also say how often it's going to emit and what variances to apply each time it emits a new one. Okay.
So the emitter uses a particle, right? So this is the particle. Okay. So this is the sphere location. You can add different locations, like box location. Instead of right now, they are spawning in a sphere.
Right. If you drew a line around the bands in which they can spawn.
I guess probably you can somehow show the collision bounce. Okay, there you go. Well, it doesn't look right, but
yeah.
Maybe they're scaled. That's why they're. Not sure.
Yeah.
Okay. Set fixed bounds. Ah, okay. All
I
right.
think that is.
Now I was using fixed bounds, right? That's why it's using this one. Okay. All right. So initialize particle is important, I guess. Lifetime.
So lifetime is
for each particle.
yeah. So are we in the options for the particles now? Sorry, rather than the emitter.
Yes.
Yeah. Okay.
Here, particle spawn. Under particle spawn, I'm looking at initialize particle.
Okay. So here it's going to live between 3 and 4 seconds, right?
Yes.
Okay.
And this is a little confusing, but you can change this by, like, you have many options here. If you want it, like, power of something, radians to degrees, or a sine value.
I can't even think how or why you'd use that, but I'm sure there's reasons.
Uniform ranged float.
Right.
So you can select a minimum and a maximum.
Yeah. Yeah.
Okay. Here, for example, I tried using lerp, but it didn't mean anything.
Yeah.
I'm just playing with them.
So is that to change the color? Choose a different color? Are you trying to do there?
Yeah, I'm not sure. I was trying to. Let's see. Let me revert it. Okay, so we have only one color by default. And this doesn't apply because I guess I'm not using the color.
Is it using the material color?
Yeah, probably. Not this one, this one. We are actually using it, right? Yes. Well, I played with the alpha earlier. It seemed like it was working. Well, when I disable it, it works the same.
Yeah, I'm not too sure about that.
We'll see. Yeah, this is always confusing to me.
Yeah.
Size is straightforward.
The mass, I'm not 100% on.
Mass, so you can also use physics.
Okay, for them to like float and stuff, is it?
Yeah, okay. Like apply gravity and stuff. Also, they can collide, I guess.
Interesting.
Sprite rotation. So this is the starting rotation, right? It's not like the rotation speed or anything. It's the starting rotation. So it's a normalized angle here.
Right.
So it's between 0 and 1.
So with that, normalized being that's between, what, 360, but normalized? Yes. Okay. But on which axis? I'm confused.
I guess if they have ranged float, it should. We also have the particles looking at the camera all the time.
Like billboard style, is it?
Yes. So okay. It doesn't matter, I guess. It's 2D. So yeah. It only has one axis. But you can also change this to a vector 3, probably uniform vector 3. If you're using a mesh instead of a 2D particle, you can also emit 3D meshes.
Right. Interesting.
I don't know where you do that though. Mesh, yeah. Initialize mesh, reproduction sprite, sample static mesh, maybe. Yeah. We have to extort that bit. Okay.
I guess you could make an effect to look like a bunch of like coins, for example. You might have a static mesh with coin.
Definitely.
It'll be like a bunch of them like spraying out or falling out, and then they disappear because they're not actual objects. They're just a render of a.
They can even collide with the environment, then disappear.
Yeah. That's interesting.
And look, they have mesh attributes here even.
Okay.
But we're not using meshes, so it's grayed out. Add velocity in cone. I mean, we don't have to talk about all of these because like you can add hundreds of them.
Were these
But
ones that you added, or were a lot of them there already?
no, this was here already, but I changed the velocity to 0. I didn't want them to move, but let's try adding some velocity.
Oh yeah, they kind of float, do they? Up a bit? I don't even know. Actually. Yeah, they seem to be going upwards. Yeah.
Yeah,
Okay.
I can see.
So I remember this sort of thing where you design like it's like a line direction or a shape that they're going to be moving in, and
Yeah.
this is the first we've actually seen any of that sort of stuff in.
Yeah, I only have 1 Z and 0 X and Y, so
So it's
they're just
directly up.
going up.
It'd be nice to like see which way. It's like the cone, if that makes sense, you know.
Yeah,
But that's
I
okay.
don't know. I don't know if they have a debug for it.
Yeah.
Oh, it says color here. Maybe this was overriding the initialized particle? Yes, it was. So that's the reason.
Oh, where was the override color thing? Sorry.
So remember it was saying it has an order.
Oh
So you
yes.
can, right? So this was overriding the initialized particle thing.
Okay, because you put the color in yourself.
Okay, let's go and try.
Or get rid of that even.
Uniform range linear color. Let's say it should start from 0 alpha and blue, and the maximum is red. It's 1 alpha. Wait, sorry. Yeah. Well, they're just.
It'll be all shades between a transparent blue and a solid red, is it? Yeah, if you do it like that, then.
Yeah, so it chooses a random color between these two colors.
Yeah. How does it do linear color in a sense that is it just the color wheel, I guess, right?
Probably, yeah.
Okay.
And like you can see purple and pink, so it's between, yeah. I can try something closer to blue, so yeah, it's definitely the color wheel.
Yeah.
Particle update. This is really long. Like.
So this is what you want to happen while it's alive,
like
then, right?
collisions, beams. I don't know what beam is.
Yeah.
I can only guess. I mean, in the morning I watched this Unreal tutorial from Unreal.
Oh right, okay.
They were showing. It was silly, complicated, and advanced. They were making a hologram. So they have this drone flying over a city, and it has a camera target in it, which captures the view under it, and stores it into a texture. So you use that texture to create a hologram of the city and the with like balls. With tiny balls, it creates a hologram of the city. It uses the Z values as well.
Right. So it's like a depth map sort of thing.
Yes, a height map. But also it has color value, so you see the colors of the city in different sections. And also the drone moves and particles like balls move, lerp into the next position.
Interesting.
Yeah, it was
and massively
silly
complicated.
and that was the first video I watched about Niagara. What the hell?
Yeah. I guess it's cool to show all the things it can, the high end of what it can do, right?
Yes.
Take stuff live from the game and process it and handle it, I guess, right?
So I switched to particle update. There's a particle state here. Kill particles when lifetime has elapsed. So basically it checks if the lifetime is elapsed or not on update, and it kills it. I guess this is what it does. It's weird to have a component like this here.
Kill particle when lifetime is elapsed. I'm guessing that.
So you can assign a lifetime variable from elsewhere here. You can link a blueprint or something maybe.
Right, okay.
But we're using the particle lifetime and the engine delta time. So
Right.
we're giving you the freedom to change these, but you wouldn't be changing these, I guess.
Yeah.
Gravity force, I don't have any. Let's
Yeah.
try.
So will they go up and then fall down?
980.
Interesting.
So
Yeah.
there goes our fountain.
They go up and then gravity brings them down.
Drag, yeah. Well, drag doesn't change much. So it's the friction, you know.
With the air friction?
Yes.
Yeah.
Scale color.
So is this scale and color? No. Oh,
No.
so you can scale the color to be more intense, is it? I
doesn't-
guess. The alpha,
okay.
I would
RGB and
understand.
alpha separately. So
Oh, so they fade out, sort of thing. I'm guessing it's doing here,
yes,
right?
yes. But where's the so? How can I see them separately in the graph? Do I have to? Okay. So they have the same thing.
Is there another curve underneath? No. Yeah, I don't know.
All right.
This one seems under alpha. The RGB doesn't seem to have a graph. Can you see how it's under that node?
Yeah. True that. So this is the alpha. And if we choose to not to fade it out. Sorry. They still get fade out because it's a sprite sheet and the animation has a fading out.
Oh, right. I see that would right. So you can't. That means if we just had a normal image like Joe's face, which we could use.
But this was painful to do in Cascades, though, with weird ass values. You change
really?
values to achieve this, and there's another graph editor on the side, but it's not very easy to use as well. So
right.
Good luck with that already. Solve forces and velocity. Okay, you can set limits to the acceleration and speed.
Okay. Yeah.
Here, this is important. I added this, but before that, where is it? I need to find this thing. It should be in particle, isn't it? Wait, sorry. Okay, let me search for it. Sub. No. That's okay. Let's go back to the emitter. Maybe there's more options here. Okay, the sprite renderer. We don't have the sprite renderer here, really. Okay, we have it. Sorry.
So okay, right. I see.
Yeah, we have a sprite renderer. So I changed the sub UV to 8x8 because of the sprite sheet. Remember, it was 8x8, so we have 64 images.
So that's the subdivision, is it? Right.
I don't know what this does. Maybe if true blends the subimage UV lookup with its next edges. Okay, yeah. Let's do that then. And then I added the sub UV animation. So before I edit this, it wasn't showing anything. Actually, it does, but it wasn't showing anything because remember the first The first frame is nothing.
Ah, okay, right, yeah, so you don't see it.
Yeah, that's the reason. It took me some time to realize
So,
that though.
hang on, go back, where were we? The UV yeah, so what does UV mean in this sense here?
The UV, it's using the sprite sheet's UV, right? And divides it into different sections.
So the UV in this, sorry, the term UV to me, I thought was the unwrapping of texture sort of UV.
Yes, it is unwrapping, isn't it? Because think of it like remember we had islands in Blender, right?
Yeah.
So
Are we
let me
just
just
splitting it into 8x8 islands?
yes, actually it does that. So it has different islands here. This is an island, this is an island, this is an island. So their approach is okay, I guess.
Right. Yeah.
Call it a UV, I mean.
Yeah. Sorry, just terms like that for me. It's always gonna. If I don't ask, it's gonna confuse me why we're saying UV. But
Now also, I guess there you can use it on a mesh here as well,
yeah, that's true.
and animate the UV again.
Yeah. Okay, so they could be like balls, for example, rather than billboard sprites,
Yeah.
and then it would be
So
a UV.
I made it 64 frames, changed the number of frames to 64, and
Right.
kept it linear.
So random would be weird, right? That means it's gonna just choose different frames.
Yeah, but random is also useful if you want to do like I don't want them to animate, but I want some variants.
Okay. Yes. Yeah.
Change this to 1 and keep it random, so it will spit out random stuff, but it'll just
Yeah.
sorry, this should be 64 though. I don't want it to be animated, of course. Like we need to change the random range float to maybe keep it what it is.
Yeah.
I don't know. Yeah. Okay. That's pretty much it.
Yeah.
If,
No, that's it's a little bit. Sorry, Apollyon adds a little bit in chat based on what we were saying. So he says it uses a grid and goes through them by changing the position on the
yeah, the
texture.
colors, right?
The what? Sorry, the color.
What is he talking about?
I think he means in terms of how, if we have the texture, which is just the grid of images, but it looks at a different position on that kind of sheet in order to.
Yes.
So it's like texture coordinates or whatever sort of thing, if that makes sense.
Mm-hmm.
Krasenstein, wonderful Krasenstein, welcome along. Hello, Kras. Hello, Des. How you doing? What up? We're trying to learn a bit about particle systems today. I know very little about it. I know even less about it in Unreal. And yeah, we've just been having Brain had a bit of a play around this morning, so we've just been having a look what he's learned. Probably going to go through a little bit of a tutorial this morning to try and learn a little bit about that and get a bit of hands-on with using it, following some steps, so we don't get overwhelmed because there's a lot of things. There's so many different properties you can change, and it's one of those things where you can change it and see how it looks. But then it depends. If you don't really understand it, you might not be able to see how it looks. So it's a tricky one. So have you got one which is just a one kind of ball glow thing, is it? That texture, sorry. I was
You mean
looking at
this one?
Yeah. Or does that have a bit of a pattern to it?
I was planning to add some flares and stuff. But, I failed achieving this look. Maybe this will work because like when I go into particle emitter lights, it shows something like this.
Oh.
There's something wrong with the transparency. Let's see.
Yeah, I'm like another area I'm really not very good with chat is with materials and
texture, clouds, light material. Bring it here. Alpha.
Do you need the emissive in there as well?
Okay, this looks
Interesting.
NPE lights.
No, it's still.
Maybe it's still thinking. Yeah.
Ah,
there
there
you
we
go.
Okay, no, it does look cool.
Yes, it does, and I think we want it to be emissive as
Yeah,
well.
that's what I was thinking when on what you said earlier. Let's see how that looks.
It looks similar, but we can make it additive instead of translucent. Here. But also, I think I saw it somewhere in a tutorial that you can crank up the light render stuff and it shines more. But I don't know where, to be honest. Render, not here.
Sorry, Crass, you said you worked on getting Photon up and working for the 1v1 spellcasting game. Photon is that the Unity what?
Multiplayer.
Ah. Cool. That sounds pretty cool. How have you found that process, Crass? And are you hosting it on a server, or is it going to be like peer-to-peer sort of thing, where the one person's the host?
Is it here? Light renderer.
Relatively straightforward. Photon uses a region-based cloud to centralize the ping. Do you need to pay for that then? I'm not too sure how it works. So we're stepping through the frames here to see.
No, it's playing it automatically. I was looking at my other screen, sorry. So it says render incompatible with sim target mode, render incompatible with sim target mode 1. Okay. So sim target, do I need to change it back to CPU simulation and go to render? Okay. Doesn't complain anymore, but doesn't change anything as well.
Yeah.
Where's my color? Scale color. Let me delete this.
I'm trying to have a clue what's going on. Only over 20 concurrent users. So that's still fine. Like for a game where you don't need to have more than 20, if they do a free service, that's crazy good. Can you get people playing from different regions though? When you say region-based cloud.
Did you find the tutorial to?
The thing I was going to go through?
Are you going to use the Unreal Engine tutorial?
I was going to go through the quick start.
Okay.
So yeah, I'll get that open.